Hello friends, myself Amar Mudiraj from Marathwada Institute of Technology MCA department. In the last lecture series, part 1, you have discussed the what is process scheduling, what is process scheduling criteria, and what is optimistic process scheduling mechanism, which operating system is following during the process execution. Now in this video, we are going to concentrating on what is scheduler, the scheduler types, and process scheduling types during this process management is going to be follow. Let's begin with the scheduler. Sometime when processes are executing during their execution, so process need to be migrate among the various process scheduling queues like ready queue, waiting queue. Sometime process need to be get execute in a new state, then it will send it to the running state, then finally it will be transferred to the termination state. So it must get selected first for execution. So a job of a scheduler is nothing but it try to selecting a process which is going to be executing for a various queues, like which process will send from new state to ready state, which process will send it, or having a multiple number of processes available in a ready state for execution. So among that all ready processes, which of the process need to be get select for a running state. And if running state is executing and having some IO interrupts or some kind of events are get called, so the process will send it to the waiting state. In the waiting state also we have multiple number of processes, so we maintain a waiting queue there. So which process need to be get execute or shift or scheduled from waiting state to ready state, and again from ready state to running state. So that entire selection criteria will going to be decided by the process scheduling or process scheduler. Apart from, so the two types of schedulers we have, that is called a long-term scheduler, which can be called as a job scheduler, which selecting which process should be brought into the ready queue. That means when the process will get created, its process control block is get created into new state. So what will be the criteria to bring that process into the ready state for execution? Means all the requirement of a process as far as the resources required for execution are get created, request is get created, allocation is get happened, and according to that allocations and need, all the queue is going to be get maintaining in a ready queue, and the processes are ready with all the given resources which they require. So this time taken task is decided by the long term scheduler, and the same pattern in a short term scheduler who is called a CPU scheduler, which selecting which process is going to be execute next or allocating the CPU. Means a job of a short term scheduler will be the scheduled processes in a ready state need to be bring into the main CPU execution. Means a processor is going to be allocating to those processes who are in a ready state. So that decision making will be take care in the form of short term scheduler. In the next slide we are going to discuss quite detailed. Process schedulers are, when we discuss with the short term scheduler, it invoke very frequently, means they need to be work very rapidly or fastly, sometime a millisecond. The decision making about the short term schedulers is nothing but we need to only bring a data from or processes from ready state to running state, that's it. They don't need to be bothered about that on which criteria they need to be bring or something else. Only they need to be brought from the main memory's ready state to the process scheduling execution. That's why they are quite fast in compared to the long term scheduler. Now name itself defines it's a long term scheduler. It taking a long term to invoke very infrequently. It means sometime it will deciding that which process will go in a ready state, what will be the criteria, what is the priority, what is the requirement of resources, whether the resources are available or not, whether they can be work or not, whether the process will execute completely or partially, whether it is cooperative or non-cooperative process. That entire part is going to be decided by the long-term scheduler, and that's why it take quite time. As far as the degree of multi-programming concerned, long-term scheduler will try to control this entire degree of multi-programming. Means a ready queue or waiting queue will going to be deciding that how many processes are going to be execute at the same time, how many processes are going to be run concurrently. So that will be deciding by the long-term scheduler. That's why it have ultimately direct and indirect control over the degree of multi-programming. The last part in this given schedule is nothing but a process scheduling and their types. Allotment mechanism of CPU to the process is actually deciding what are the types of scheduling process we going to be use. There are two types, that is called preemptive and non-preemptive. In normal language, preemptive means a permissible or permittable scheduling algorithm, and another is non-preemptive, that means no permission for a CPU to get allotted to the process. So let's have a definition. That is, a preemptive means once a process is get entered in a running state, means a process is get allotted by the processor for execution, it can permittable to remove from the processor until it has completed its execution. That means we can allotting our resources or processor to the process. So before that process will complete its execution, we can roll back the processor and we put another process for the execution on the processor. Second type of processor scheduling or process scheduling is nothing but a non-preemptive. Once a process entered in a running state, means it allow a process to execute, it cannot remove or it cannot permit to remove from the processor until it has get complete its execution. That means what, the process is having 10 CPU cycles to execute and process is get allocated to the execution for a processor. So unless and until all those 10 CPU cycles are get executing, till that point we cannot roll back that process or we cannot stop that process execution. In the preemptive one, it's a different one. When a process having a specific number of CPU cycles need to be get happen during the execution, we can roll back or we can bring that process from this processor for a time while and we'll put that process into the waiting state for execution, or in a directly interrupt get called and it will be sent it to the ready state, and we can bring another process to the processor to get execute. Means a process can get rollback from the processor before the completion of execution. We have preemptive scheduling algorithms like shortage of first, priority scheduling, or round robin. In a non-preemptive one, we can again have a first come first serve, shortage of, and priority. So these are the types of process scheduling. I hope you would like to have some comments on my video that can be help me to develop my future videos with the more quality and effective way. So thank you so much for watching this video, and I request to please comment and having a like to my video. Thank you so much.